All right, everyone, it's Mr. Reedy. I just wanted to do number one with you as a guided video solution. So without further ado, let's take a look at number one. So it says the specific heat capacity of silver is 0.24 joules per gram degree Celsius. It's asking us to calculate the energy required to raise the temperature of 150.0 grams of silver from 273 Kelvin to 298 Kelvin. All right, guys. Well, let's take a look what we're going to do. I'm going to do the problems, guys, on this side of the page here, just so I have a little bit more room. So, of course, we're working with number one. We will be doing A first. Okay. Keep in mind, guys, we're going to be calculating, or at some variation, heat. So we're going to need Q equals MC delta T at some capacity. Now, some of these equations might ask us to solve for M, the specific heat, or delta T. So just keep that in mind, but we do need this base equation. All right, so let's get into A. So A is asking us to find the heat, right? So we're looking for heat here. Okay. Well, that's a pretty easy thing to do then, because all we have to do is plug and chug. So Q equals, in this case, we have 150 grams of silver times the specific heat of silver, which is going to be 0.24 joules per gram degree Celsius. And then our delta T is going to be 25 degrees Celsius. Folks, notice that I went and put the units back to Celsius instead of keeping them in Kelvin. The reason for that of course, is because our specific heat was given us in joules per gram degree Celsius. So I'm just matching my units. I plug this into my calculator and I get 9.0 times 10 to the positive 2 joules of heat. All right, so that's letter A. So B then is asking us the amount of energy required to raise the temperature of 1 mole of silver by 1 degree Celsius. Well, guys, 1 mole of silver, right, is equivalent to 107.87 grams of silver. That's the mass right off the periodic table. So again, guys, I'm just going to plug these values directly into my equation. So we've got 107.87 times our specific heat, 0.24 joules per gram degree Celsius, times 1 degree. Plug this into my calculator, and I get 26 joules of energy is required to change the temperature of silver by 1 degree. Let's move into part C. C says it takes 1.25 kilojoules of energy to heat a sample of pure silver from 12 degrees Celsius to 15.2 degrees Celsius. We want to find the mass of silver. So for this question, we're looking for the mass of Ag. Okay, that required to do that. So Q equals MC delta T here, right? But this time, guys, we are solving for M, right? We're looking for M, not just Q here. So M then is going to be the heat over the specific heat times delta T. Okay, so I'm going to plug my numbers in. So we get 1.25 joules, okay, of energy there. Okay, notice, guys, that I said joules because, real quick, guys, let me fix that. All right, guys, notice that I called a mistake I made there. It should be 1,250 joules. All I did, guys, was I took my 1.25 kilojoules of energy and I converted it into joules here, right? So that's where I got the 1,250 joules from. Now, again, the reason why we have to do that is because the value of the specific heat capacity given to me, right, which was all the way up here from the original problem, was 0.24 joules per gram degree Celsius. Again, we need our units to match. Then I'm going to divide that by 0.24 times delta T, which in this case is 3.2. Our mass then is equal to 1,630 grams of silver, or we could say 1.63 kilograms of silver. Either would be correct. And with that being said, guys, that's the end of today's video. If you have any questions about it, please shoot me an email.